Hey guys, what's up? My name is Gabe and this is Games with Gabe, and this is the next episode in the Coding a 2D Game Engine in Java series. So in this episode, we're not going to be getting all of this done, but we are going to start working towards this. I went ahead and started coding quite a bit in the development branch just to show you guys what we will be working towards. So this is sort of where we're headed, and it's going to take quite a bit of changes. I have a link to the GitHub diff so that you can check that out, but basically we'll be able to add objects, duplicate objects, and then you'll see this has physics attached and everything. We can play and stop the scene. We can delete objects. And then if I go into here, I can change some of the physics things. So like if I change this to a static object, it won't move, but it still has physics applied. So it just gets stuck there. And then as you can see, we have physics like completely working, and we can play and stop our level just by doing this, which is really cool. And it's just a lot of cool stuff that we will be getting to. So if you want to see all the changes I had to make to get here, check out the description for a link to the GitHub diff, which looks like this. There's quite a bit of changes in here because I did a lot of refactoring and stuff too, so that we can get to a better point with the code base and hopefully have it working a little bit better. But you can check this out, and then if you want to work ahead. In this tutorial, what we're specifically going to be doing is we're probably going to be adding the functionality so that we can actually create a physics object, and then so that we can right click in this properties window and then hit like add rigid body or something. So if I were to place in a new object in here, it doesn't have a rigid body, but if I right click over here, I can say, hey, add a box collider, and then that adds a box collider as you can see, and then I can say add a rigid body. One other thing that we'll be doing, which is kind of cool, is like if I toggle the physics debug drawings, so it's kind of glitching out here a little bit, but this is basically Box2D's physics debug. So like I had to enable Box2D's physics debugging drawing because I couldn't really tell what was wrong with mine, and so I did all that, and then I'll probably just be giving you guys the code to that so that you can use it whenever we get to a point where this will be necessary. But yeah, so you can see that this all works just like you would expect it. Okay, so let's get started, right? Very quickly, before we jump in and start coding, I do want to mention, because we will be building this event system. Remember I had talked about how I wanted an event system and it will just make some things nicer. I can't remember what I specifically wanted it for, but we're going to be doing that in this episode as well. This shouldn't take too long because setting it up is actually pretty simple. So the premise of an event system is basically, and we're following the observer pattern here too, which I'll have a link to the description to a article on this. But basically, we want a bunch of observers that say, hey, every time there's an event, and maybe when there's a specific event, I want to be notified of this. We don't have the specific events for this episode. We're just be doing like generic, hey, whenever something happens, I want to know about it. And then we have some event system that basically says, okay, I'll go ahead and notify you of those events. And this is literally all there is to it. So event system will literally just look like a class that has a list of observers, right? And so whenever we call this an on notify message to the event system, so like maybe we want to notify of something, then we just go ahead and loop through all the observers and call their abstract on notify message. The thing that makes this so powerful is that our on notify will basically have two parameters, one which is a game object, which I'll preface with GO, and the second which is an event. And the event can hold data, and it can also hold just a simple event type. The reason this is so simple or so powerful is because now all of a sudden we have a way to go and reach out to hundreds of other systems potentially that wouldn't be very performant and just notify them with a specific game object or nothing. If we don't want to, we can just leave that null and then an event, and they'll be notified and we don't have to couple them. This is completely decoupling. So we do have this global event system now, and we do have to manage these observers, but it's a pretty good pattern. This isn't very performant too, so we're only going to be using it for tasks like on, begin, play, and stuff like that, right? So we'll have a bunch of different event types that we can just call, which are very simple, and that will make sure that we're not using this like inside of a core game loop or something, because then it will become not so performant. We could improve it in the future if we want to as well. Okay, so this is the basic premise of the whole system. Let's go ahead and code this because I think it's pretty cool, and it'll definitely help clean up our code a little bit in some areas. All right, so let's very quickly code up that event system or observer system that I just talked about. It really is as simple as I just talked about too. There's nothing too complicated. So let's just go into our Java, and we're going to create a new package, and I'm going to call this observers. All right, and so this will sort of contain the code that relates to this whole observer system. Then we'll go into here and we'll create another new class, call this event system. And so this will sort of be our global event system that handles all the observers. We'll create another class, call this observer. And this will be an abstract class that has that onNotify method. And then we'll create a package, and we're going to call this events, and just create everything up front. And then inside of here, we'll create a new class, call this event type, and this is actually going to be an enum. So click that enum. We'll have that, and then we're going to go ahead and create another new class inside of here. Call this event, and this is just going to be empty for use to be extended if we want to send a specific event in the future. Okay, so let's go to the observer, because this is sort of where all the magic happens. And it's literally just a simple, we're going to call this an interface so that other classes can implement it. And it literally just says onNotify, and it takes in a game object, and it takes in an event. And we'll hit Alt Enter, import that. And I imported that from the wrong, wait, no, I did. Okay, make sure you import it from the right package. This is literally all that's inside of observer. It's just an interface that says, hey, onNotify, and then we send it a couple things. And now we can implement this in any class, and then they will be notified whenever an event happens. For the event system, we're going to keep it just as simple. We'll go into here and we'll just say private static list of observers. So we're going to hold the list of observers, and we'll call this observers equals a new array list. Then down here, we're going to say public static void add observer, which will take in an observer. And we'll just add it to our list of observers. So we'll say observers dot add observer. And then we'll have one more function called public static notify, and this will just take in a game object, obj, and an event. And I will import that using Alt Enter, and also this function should return void. Okay, and then this will literally just say for observer in observers, observer.notify.onNotify, and then it'll pass in the object and the event. That's all we need. This will now work with our game engine and allow us to notify things in completely different classes of events going on throughout our system. Now, unfortunately, I don't think we're going to have time to actually use this today, but we will be using this like in the next episode or something whenever we go to implement our physics. And the way it's going to be used to is an event actually will have an event type, and we'll just call this event, or we'll just call this type. And then this will be public, and it will just sort of tell us what type of event we're using. And we'll create a couple. We'll say game engine start play, game engine stop play, and then we'll have one for save level and one for load level, and then user event. The user event is sort of just a catch-all to say, hey, if in the future one of the users wants to extend this and create their own event or whatever, they can just use it and then say they have a user event and then do what they want with it, and we'll just ignore it because it's a user event. It's not one of our built-in events. Okay, and so this you can sort of probably see how we'll be using it in the future as well. When we get a game engine start play, we can start the physics, and then when it stops, we can reload back to where we were before we started the physics and everything. But we'll see how to use all this in the next video. I just wanted to put it in place so that we have it. Okay, let's go back into our physics 2D now, and we're going to need another function in here, which I am going to call public void add, and this will take in a game object, go, and this is literally just going to add it to the physics engine. Okay, so we're going to add it to Box2D throughout here. Now, what I'm going to be doing is basically taken directly from his tutorial that I showed you in the last one, which is basically just the hello Box2D, and that's where I'm getting all of this information from, that in his documentation. So let's first of all say rigid body 2D rb equals go.getComponent rigid body 2D.class. So if a game object has a rigid body, then we will add it. So we'll say if rb does not equal null. So if they do have a rigid body and rb.getRawBody does equal null, the rb.getRawBody basically tells us, hey, this has not been added to the physics engine. This has not been added to Box2D yet. But if this is null. If this is not null, then that means that it has been added Box2D, and we don't want to add it a second time. So this is just like sort of a safety in case somebody tries to add the same game object twice to the physics engine. Okay, then we're going to get a hold of the transform. We'll just say transform equals go.getComponent. Actually, we can just say go.transform. Okay, that's nice and easy. This is where the Box2D code starts coming in. So we'll say body def, which is the body definition, equals a new body def. And this is how we will tell it how to create the body. So first of all, we're going to say body def.angle equals, and then we're going to go ahead and say float math.2radians transform.rotation. Then we're going to say body def.set or .position.set, and we're going to give it the transforms position.x and the transforms position.y. And we're just going to set the rest of these settings directly from whatever the user provided. So we'll say the angular damping equals the rigid body's angular damping. We'll set the linear damping to the RB's linear damping. We'll set fixed rotation to the RB.is fixed rotation. And then we'll set the body's bullet to RB.is continuous. So bullet is basically what it's called whenever you have a continuous collision, and this just means that there won't be any ghosting of objects. Now, if you don't know what that means, I suggest you Google it, but basically it just means that if you have a bullet, it's called bullet because this is usually where it occurs, but if you have something traveling like as fast as a bullet, and say you have a wall here, sometimes what happens is the bullet is right here, one frame, then the next frame it's over here, and it just clips through the wall. So when you turn this bullet on, it basically just says we're going to use continuous collision, and so then it makes sure that the bullet actually hits the wall instead of just going right through it. That's all that is. Okay, then we're going to say switch rb.getBodyType, and we're going to say case kinematic. This is just standard physics terms. If you've used Unity, you'll probably recognize these, and we'll explore them more as we actually code them and see how they work. We'll say if the body types, so if we have a kinematic body, we just want to set the body definitions type to org.jbox2d.dynamics.bodytype.kinematic. And the reason we have to do it, okay, and I guess in my old code I had done it the whole path because I had some name collisions, but it looks like we're good in this case, hopefully. Then we'll say case static, and we'll take body type's definition to static, and then we'll break, and then we'll say case dynamic, which is probably what you'll want most of your physics types to be. That and static are actually probably what you're going to be using most of the time. And then we'll say break on that as well. Okay. So this creates the body definition, right? This creates what we're going to use to figure out how much friction, all that type of stuff. And I think I might have actually missed that as well. Oh, no, I didn't miss that. It's just linear damping. Okay. So yeah, we basically tell it this is like angular friction. This is linear friction. And then we tell it whether we want it to be fixed rotation, so that it can't rotate or not, and all that stuff. Next, what we have to do is basically tell it what the collision shape is. So we, in our game engine, we're currently supporting just circles and boxes, right? So you can have a circle or you can have a box. And we have to tell Box2D that by creating something called a polygon shape. And so the way I did this is I just say polygon shape equals a new polygon shape. And then we can set this as either a circle or a box, which is good for us because we don't really know. And then what I'm going to do is I'm going to say circle collider, because we don't know if we have a circle collider or a box collider at this moment, is null. We'll actually just set it like that. And then we'll say Box2D collider. Box collider is what I'll call that. And then we can say if circle collider equals go.getComponent circle collider dot class does not equal null. So you may not have seen this syntax. It's probably more common like C++ and stuff, but basically all this does is it assigns this go.getComponent to circle collider, and then it checks and sees if that was null or not. And we just have to declare them beforehand in order to do this. And the only reason I'm doing it this way is because then we're going to say else if box collider, and we're going to do the same sort of thing, equals go.getComponent box collider dot class does not equal null. And it literally, it's probably not even worth it. It saves just one function call to this, which we know is just a linear search. So theoretically, it probably saves a tiny little bit of performance, but it's really not necessary. So if you don't like this syntax, just assign these up here and then just check and see if they're null down here, which is all we're really doing. So if it's a circle collider, what we say is shape.setRadius. And I'm not actually sure if this is going to be correct yet, but we will find out in the future. Circle collider. And what I mean by that too is just if it's like in the correct position and stuff. I haven't tested this one yet, but the box one I know for sure. And then we'll just get the radius. So this will just set the radius to whatever our circle is. And this also implicitly sets this polygon shape to a circle. And we'll say bodydef.position.set transform.position. And actually, I'm not even going to do this part because we don't know for sure if that's going to work yet. We'll settle that in the future. Okay. Then if we have a box collider, we'll say vector2 half size equals, we're going to say new vector2f box2D collider or box collider dot get half size dot multiply by 0.5f. And you may be asking why I'm multiplying the half size by half. And that's because when I was testing this, for some reason I had to multiply it by half again in order to get it the correct size in Box2D as it was. So like all these numbers and stuff are just so that I could get Box2D to match what is actually showing in the engine. And we'll talk about that a little bit more once we get some debug drawing up and you can actually see what that means. And then we'll say vector2f offset equals Box2D collider or box collider dot get offset, which we don't have yet. We'll add that in a minute. And then we'll also say vector2f origin equals new vector2f box collider dot get origin. And we will also add that. So if we go into components, I'm going to go ahead and create a new class. We'll just call this collider. And then inside of this collider class, which we're going to say extends component from our components class. And then we're also going to make this abstract. This is going to have a public or private vector2f. And this is going to be our offset equals new vector2f. And so this is basically like sometimes when you import assets, you need to move the colliders around a little bit to get them to fit correctly on the asset. And this is what this will be used to. We'll just have a public vector2f get offset. And this will return this dot offset. All right. And then circle collider and box collider will both extend from collider instead of that. So we'll just have this extend collider. And we'll have this extend collider. Okay. And then we're going to go ahead and also add in an origin. Vector2f origin equals new vector2f. This will probably remain 0, 0 like for most of the time, but I figured we could have it there just to mess around with it in the future if we want and see how that works. And then we'll have a vector2f get origin, which returns this dot origin. Okay. Now we can go back into our physics 2D class. So we have all these values now. And we want to pass them to Box2D so that we can set this all correctly. So we'll say shape.set as box, half size.x, half size.y. And then we'll say new vec2 origin.x and origin.y. And then the angle, which we'll say is 0 for now. We may change this in the future too. Who knows? And all this basically does is it just sets this polygon shape to the shape of our box. It's literally all it's doing. And then we'll say vec2 pose equals bodydef.position. And we want to basically move Box2D's box to fit perfectly over our box. And the way we do this is we say float xpose equals pose.x plus offset.x and float ypose equals pose.y plus offset.y. So we're basically telling Box2D, hey, we're going to sort of change it so that it takes into account the offset, and then we'll mirror this inside of our rigid body. And then we'll say body definition.position.set xpose and ypose. And a lot of this may not make sense right now. Don't worry, it will once we actually start messing with the stuff in the editor. We're basically just doing all the settings and then sending it to Box2D so that it can use them. Then we're going to say body equals, and I'm going to hit Alt Enter and import that. This.world.create body, and then we're going to pass in the body definition. So now we've just added this to Box2D's engine, and then we're going to say rigidBody.set raw body to this. Now we have a copy of that, and then we're going to say body.create fixture. We're going to pass it our polygon shape, and we're going to pass it our mass. All right, and then that should create the rigid body inside of Box2D, and then it should also assign this create fixture basically says, hey, create the polygon shape and actually attach it to this rigid body. Okay, so now that we have a way to actually add game objects with rigid bodies and stuff, we need a way to add the rigid body to our game objects. So how do we do that? Well, we can go into our editor and we'll go into our properties window. Remember how I was right clicking on that and we sort of were able to add things. This is where we will add all that code. And so we'll say if the game object is not null, then right before we actually ImGui everything, we'll say if ImGui dot begin pop-up context window, and I'm going to call this component adder. This part will not be seen by any of us. This is just the ID, so this is just used internally. Make sure it's unique. And then we'll say if ImGui.menuItem, and then I'm going to say add rigid body. So if they click add rigid body, we're going to say if active GameObject.getComponent rigid body.class equals null. So if they don't already have one, then we'll add it. We'll say active GameObject.add component new rigid body. And you know, maybe in the future you will want to have multiple components of the same type added. So we'll think about maybe not having this in the future. But for now, we'll just say if they don't already have it, then we'll add it so that they can only have one at a time. And then right down here, we'll say if ImGui.menuItem, following that exact same pattern, add box collider. So if they click add box collider, then we're going to copy this and then say add a new Box2D collider. And then we'll add a new Box2D collider. Copy this one more time. We'll do the same thing for circle collider. So we'll say add a circle collider, and then we can say if they don't already have a circle class, then we'll add it down here. Hit Alt Enter, and I'm gonna, whoops, that imported it from the wrong library. So I'm just gonna remove that, import this from the correct, which is circle collider. That's why it wasn't finding. Okay, so just make sure you have the right names and you should be good. All right, so now we can add circle colliders and everything, and then make sure at the end of this you do ImGui.end pop-up. All right, so what did that do? This basically makes it so that we can now go into here, and then we click on an object. You can right click inside of this window, just that window. It opens this up. We have these three options. If we hit add rigid body, then it adds one. If we hit it again, it doesn't add a new one. And then you see we have everything here just like we would want it. Now, one last thing, we don't want, well, maybe in the future we will, but for now, we don't want to add box colliders and circle colliders. So we just want to say if they don't have a box collider and they don't have a circle collider, then we'll add a box component. So we'll say circle collider.class, and then I'll just copy that. Equals null as well. And then we'll go down here and we'll do the same thing. So if they're trying to add a circle collider, we just want to make sure that they don't have a box collider, because then that'd be kind of weird with the way we have things right now. All right, so that should literally just do the same thing. But basically now, if we click onto this and if I hit add box collider and then try to add a circle collider, it won't let me, and it won't let me add any of those as well. All right, so we have this. And now we basically want that play stop button thing that I had up here. Well, that's actually going to require quite a bit of refactoring, and I want to keep these episodes pretty self-contained. So I think this is going to be it for this episode. In the next episode, we will begin refactoring a lot, start using that event system that I talked about, and add in this play stop button up here so that we can actually play our physics simulation. That is it for this episode, though, guys. I hope you enjoyed it. If you did, please hit like and subscribe, and I'll see you in the next episode, where we will hopefully be getting closer to something more like this, where we can actually have our game engine that plays some physics, which is pretty cool. All right, see you guys.